Good morning, you all. Welcome to our Aptep English version. Yes, amazing news. Yeah, researchers at Mass General Brigham have found that adverse experiences in early childhood are linked to reduced development of white matter, the brain's communications pathways. During adolescence, yeah, this diminished connectivity is also associated with poor performance on cognitive tasks. However, certain protective social factors such as strong neighborhood cohesion and supportive parenting may help buffer these effects, and the findings were published in the proceedings of the National Academy of Science. White matter serves as the brain's communications network, enabling different regions to work together to support thinking and behavior. These pathways continue to develop throughout childhood, and early life experience can influence how they mature. Lead author Sofia Carrozza, PhD, and senior author Amar Dhan, MD, PhD from the Department of Neurology at Brigham and Women's Hospital, a founding member of the Mass General Brigham system, sought to explore how white matter development affects cognitive functioning in adolescence. The aspects of white matter that show a relationship with our early life environment and much more pervasive throughout the brain than we had thought. Instead of being just one or two tracks that are important for cognition, the whole brain is related to the adversities that someone might experience early in life, said Caruza. The team studied data from 9,082 children, about half of them girls, with an average age of 9.5, collected in the Adolescent Brain Cognitive Development Study. The study, funded by the National Institute of Health and conducted at 21 centers across the US, gathered information on brain activity and structure, cognitive abilities, environment, mood, and mental health too. The researchers looked at several categories of early environmental factors, including prenatal risk factors, interpersonal adversity, household economic deprivation, neighborhood adversity, and social resiliency factor. Caruso and then used diffusion imaging scanning of the brain to measure fractional anastrophy, a way of estimating the integrity of the white matter concentration and stabile count. An estimate of their strength, they then used a computational model to compare how these features of white matter were related to both childhood environmental factors and current cognitive abilities such as language skills and mental arithmetic. Behind this exclusive report, FTB English, Delhi, Bharat.